Welcome to qnawire.
In this question, we have to estimate the wavelength of the photon that is emitted during the transition from n equals 2 to n equals 1 of an electron in an iron atom. In order to do that, we first remember that the energy of that photon is given by h times f. And we have to remember that there is a relation between the frequency and the wavelength that is the following. Lambda times f is equals to c. Therefore, we can write the energy as E equals to h times c divided by lambda. Now, we can solve for lambda to get lambda is equals to h times c divided by E. So, h is a constant, c is a constant, and all we have to do now is calculate the energy of that photon. The energy of that photon is equals to the difference between the energy of the shell n equals 2 and the shell n equals 1. So we can do it as follows. E is equals to E2 minus E1. Then E is equals to minus 13.6 times. We have to use here Z minus 1 because there is always one electron shield in the nuclei. So 25 squared divided by 2 squared minus 13.6 times 25 squared divided by 1. This gives us an energy of approximately 6.4 times 10 to the third electron volts. Now we have to plug in this energy in this equation in order to get lambda as being equals to h, which is 6.63 times 10 to the minus 34 times c, 3 times 10 to the 8, divided by the energy. But the energy is in electron volts. So in order to convert it from electron volts to joules, we have to multiply it by the fundamental charge, which is measured in joules by electron volts. So we got 6.4 times 10 to the third times 1.9 times 10 to the minus 19. And this gives us a wavelength of approximately 0.194 nanometers.